In previous videos, we learned on how to find the exact values for the trigonometric functions of any special angles and quadrantal angles. And also, the other videos, we learned on how to derive and apply the trigonometric identities. So those two topics are very much important in finding the derivative of any trigonometric functions. Derivation of the derivatives and the application or solving the derivative of the trigonometric functions requires the identities and the ability on finding the exact values of any special angles. So in this video, let us focus on the derivative of the trigonometric functions. We will derive and we will also provide the graph of 6 trigonometric functions. So we will provide the derivative of 6 trigonometric functions in this video. Okay, so let us start with the sine function. So for the function of x, sine x, this is called sine x. X is the domain and the function of x is the range. So what do you think what will be the graph of this function? So take note that x is the angle, so x is the domain, so it's lying on the horizontal axis, and we have here the angles from 0 to 90 degrees, it's pi over 2, pi is 180 degrees, 3 pi over 2 is 270, and we have the 2 pi, and so on and so forth in the positive angle. So in the negative angles, meaning it is the clockwise rotation of the Cartesian plane, we have the negative 90 degrees, we have the negative 180, and negative 270, and we have the negative 360 or the 2 pi, and so on and so forth. Now, when the domain of the sine function x is, it can be all real numbers, meaning we can substitute, we can use any real numbers. So if we start evaluating the function when x is equal to 0, then it's equal to the sine of function, the sine of 0 is equal to 0. Okay, and for the pi over 2 or the 90 degrees, the sine of 90 degrees is positive 1, but the sine of 180 degrees or pi is 0. And if we continue it to 270 degrees or 3 pi over 2, the sine of that angle is a negative 1. Then if we continue again for the period of rotation, the one rotation from 0 to 2 pi, so the 2 pi, the sine of 2 pi is 0. So it starts from 0 and it ends up with 0. And we can notice that, by the way, if you connect this line, so this is now the sinusoidal curve, the sine function. So we can notice that the maximum value that can be obtained on the sine function is 1, and the lowest or the minimum value of the function is negative 1. Now in the negative angle, if we substitute the pi over 2 negative, it will provide negative 1. For the negative 180 degrees or pi, it is 0. For 270 negative, it's negative or positive 1, and back to 0 for the negative 360 or 2 pi region. So if we connect a smooth curve, this will be the result. So if we continue substituting all the possible values for the sine values in the domain of the sine function, it will provide a sinusoidal curve with a maximum of 1 and a negative minimum of 1. Okay, so as I said, this is the graph of the trigonometric function. Now the question is, what is the derivative of the sine function? What is the slope of this tangent line of any curves of this function? Then, answer is the derivative of the sine x, where x domain is cosine x. So, therefore, if you are asked what is the derivative of the sine, the answer is cosine. The question is how? What is the proof of having this value? Is this true? Then to verify is to use the slope of the tangent line formula. The limits of the function x plus delta x minus the function of x all over delta x as delta x approaches 0. This is the slope of the tangent line. So please refer our previous video on the slope of the tangent line. So please watch the video. You don't have the idea yet. So we use the principle to verify this derivative of sine function. Okay, so applying the function is sine x. So for the function of x plus delta x, this will become sine of x plus delta x, wherein the function of x is the sine of x all over delta x as the limit as delta x approaches 0. Now, next is we need to simplify or evaluate. No, we need to expand this one using the sum identity of sine. So in our previous video, we are deriving the sum and difference identities. So if take note that this is sine of x plus delta x, so we have to use the sine, cos, cosine. So sine of x times the sine of times the cosine of delta x plus the cosine of x times the sine of delta x. So by it, so this will be the expanded form for this expression, where sine of x is just copy this one. Okay, so all over delta x. Now we need to do something about the numerator. We need to combine this. We have to group this term. The reason is we have the common factor of sine x. We will, if possible, we will eliminate or remove the x. Okay, sine x. So then this is it. This is our sine x, cosine x is one, and we group it with a negative sign. And this time we will take the common factor. So we will take the common factor is sine x. So remove the or separate the common sign or take the common sign of it. So therefore this term becomes cosine of delta x, while this term becomes negative 1 because we remove the common factor. Then this is just copy, no? We just copy this one. Just copy this one. Then next is take note that we have the common denominator, so we can split this, break this into two fractions. Then after that, we can apply the we can use the theorem, no? Sum theorem, evaluating the limits of the sum theorem. So, and take note that this sine x will not be affected if we evaluate the limit as delta x approaches 0. So we can move it out the limit operator, also with a cosine function. So this will be the result. So share denominator. So this is one fraction. Apply the limit, the theorem. So we move the sine x because it doesn't affect for the delta x, the limiter. So therefore we leave it. We have only the cosine of delta x minus 1 over delta x. And the second term, x cosine x does not affect the during evaluation of the limits as delta x approaches 0. So we can place it outside the operator. So we have only sine delta x over delta x. But take note, in the fundamental In our previous video, we learned that the limit we have this theorem, the limit of the cosine of an angle delta x minus 1 over delta x as delta x approaches 0 is equal to 0, approximately 0. And also this one, this factor, in our previous video, we learned that the limit of the sine of an angle delta x over delta x as delta x approaches 0 is 1. So substituting the values, we come up, because this is 0, so 0 multiplied by any number becomes 0, so this term becomes 0. And this one is 1, so we have only cosine. So this is the proof that the derivative of sine of an angle x is just a cosine of an angle x. Okay? So this is the first trigonometric function, the sine function. Now what about the cosine function? And the graph is, okay, we will provide a graph. The sine function provides a sinusoidal graph, and also the cosine function provides a sinusoidal graph, but it differs with the points, no, in the graph. Okay, let's graph the function. Now, if the sine function, it has a real number domain, all real number, also the cosine function, it has a domain in all real number. So meaning we can substitute any number in a number. So when x or the angle is equal to 0, the cosine is 1. So this is the difference between the sine and function, because if you notice in the previous, the sine of 0 is 0, but the cosine of 0 is 1. So it starts from 1, then in the angle of 90 degrees or pi over 2, the cosine is 0. So in sine, it is 1. That's a reverse value. When angle is 180 degrees or pi, it provides negative 1. For the 270, it's 0. And for 360, it's 2 pi. So if we connect this with a smooth curve, this will be the appearance. It is a sinusoidal, still a sinusoidal, if we continue that. So in the positive side, when the angle is negative 90 over 2, it's 0. For the negative pi or 180 is negative 1. For the 270, negative is 0. And for the 360 or 2 pi negative, it's a positive 1. So if you connect this one, then we have this again as a sinusoidal curve for the cosine, and it starts from 1 and at the origin. Okay, so this is the graph of the cosine. Now what about the tangent? What is the slope of the tangent line of this curve? So finding the slope of the tangent line, it is the derivative of the function with respect to the domain x. So what will be the derivative of cosine? The answer is sine negative of x. So remember, in the cosine, the sine function, the derivative of sine is cosine, but the derivative of cosine is a negative sine. Okay, so do not forget that one. So the question is how this derivative provides a negative sign for cosine. So then the proof is almost the same. We have to apply again the formula for the slope of the tangent line. Now this time our function is cosine. So we will replace this one, function of x plus delta x, with a cosine of x plus delta x. And the function of x is the cosine of x all over the delta x. Again, in same way, we need to expand this one using the identities, the sum identities of cosine. So we need to expand this in order to provide the proof of this derivative. So take note, cosine, cos, sin. For the sine, it should be sin, cos, cosine. So apply. So we have the cosine of x times the cosine of delta x minus, because this is plus, the sine of x times the delta x. And this cosine of x was being copied from here. So just leave it as cosine. Okay, then we need to group terms. So we need to group this one with this. Why? Because we have the cosine x and we have the cosine. The purpose of grouping is to take the common factor. So do it. We have now this group terms. This one is, we just copy it. Then we have the common factor of cosine x. So take the common factor. So therefore, this term becomes only as a factor of cosine of delta x, while this one becomes 1 because we remove the common factor. Okay, then next is, take note that we have the common denominator, so we can split it, then apply the theorems, the sum theorem of limits. Sum theorem limits. So therefore, apply, and take note that this one, again, this will not be affected if we evaluate the limit of delta x approaches 0 because it doesn't contain delta x. And also this one. So when you apply the theorem, it can be placed, it can be, if you want to, move it outside from the limits. So this is the resulting term. So we divide the denominator, or we share the denominator and forming two fractions, then apply the theorem of the sum theorem. So therefore, and this one will not be affected, so this will be the result. It was placed outside the limit operator, and we have this, the limit of the cosine delta x minus 1 all over delta x as delta x approaches 0. In the second term, the second fraction, the sine x again is does not affect the during evaluation of limit, so we can move it out. Then we have only sine delta x over delta x. Now take note that in our previous video, in the fundamentals of, or the theorems of basic theorem differentiation, the limit of this cosine angle delta x minus 1 over delta x, or any angle as delta x or any angle approaches 0, the result is 0. While this one, the limit of the sine of an angle in an angle delta x over delta x as delta x approaches 0 is 1. So take note that this is 0, multiplying by any number becomes 0, so this term becomes eliminated, and we have only this one. And this is 1. Okay? So this is 1. And take note, this is negative. So therefore, we have only a negative sign. So therefore, the derivative of the cosine function is just a negative sine x. Okay? So again, the derivative of sine is cosine, but the derivative of cosine is a negative sine. So these are the two trigonometric functions, the primary trigonometric functions. Now what about the tangent? What about the tangent function? What will be the graph? So looking at the graph, now take note that tangent, okay, if the sine and cosine contains all real numbers in the domain, tangent, the domain of the tangent is not all real number. Why? Because remember that the tangent of any function or any angle is equivalent to the sine of that angle divided by the cosine. So in our previous video, the fundamental identity, the tangent is sine over cosine. So the denominator is cosine. So therefore, the tangent will not provide a value for the cosine of 0. So when cosine is 0, then the tangent is undefined, cannot be, it doesn't exist. So what is the angle that provides a cosine of 0? Okay, now take note that the cosine of 0 is 1, but the cosine of 90 is 0. So therefore, the 0 cosine found in the what? In the 90 degrees or in the 270 degrees. So if you rotate the angle end up with the y-axis, positive or negative. So therefore, we can set the boundary, meaning if we will set this line to remind us that there's no tangent function exists at this point, exactly at this point. Also with the 270 or the 3 pi over 2, or the next to 2 pi over 2 plus 90 degrees. So therefore this is. Now in the negative angle, tangent cannot be exist on this line. So this lines reminds us that tangent does not exist at this line. So no way that it will touch on this line. So there's no tangent function on this boundary. Also with the negative 3 pi over 2 and so on and so forth. Okay. Now, what is the graph between the boundary lines? So for example, negative pi over 2 and the pi over 2, what will be the behavior of the graph? Now, if we analyze from 0 to pi over 2, replacing this value. Now take note that tangent cannot be pi over 2. So approximately equal to pi over 2, it will be the result. So if you do it, then this will be the result. It will asymptotically positive towards the positive y-axis in a boundary of pi over 2. So now if you move this angle closer to negative pi over 2, it is asymptotic to negative y-axis at a value of pi over 2. So this will be the graph of the tangent line. So if you do it on the other boundary lines between pi over 2 and 3 pi over 2, this will be the result. Okay, so you can explore this using the sine over. Can evaluate this graph or find these points using the sine x over cosine x. Also with the other boundaries from 3 pi over 2 to the next of 2 pi. And in the negative, from negative 3 pi over 2 to pi over 2, no? Then we have that curve. And this curve are symmetric to all the boundaries. Now remember that this curve does not touch the boundary lines because these are the restricted lines, meaning tangent does not exist on this. It is asymptotically closer to that but not equal to that value. Okay, so this is it. Now the question is, what is the tangent, the slope of the tangent line of this curve tangent function? So the answer is that the derivative, because the derivative is the slope of the tangent line, the derivative of the tangent is just the square of the secant x. X is the domain. Why? What's the proof of that? So to do it is, take note that we will start with this function, but we need to replace the tangent with sine over cosine. So therefore, asking what is the derivative of tangent of x, then it is just the same as finding the derivative of sine x over cosine. Now this one can be evaluated using the quotient rule. Okay, so the derivative of u over v, it is u v du minus u dv all over v squared. So do not forget that theorem. So kindly go back to the previous video for the basic theorems for differentiation, the quotient rule. First is we need to preserve the denominator, as I said. Then take the derivative of the numerator. Then minus, it should be, you have to preserve the sine x, then take derivative of the denominator. That's it. Then all over the square of the denominator. So this is the result after applying the quotient rule of differentiation. So take note that this one, the derivative of sine is cosine, while the derivative of cosine is a negative sign. So substitute or replace it. So there's no derivative operator here, so we are now ready to simplify. So cosine times cosine is cosine square. negative sine times negative sine x is positive sine square of x. So therefore, this will becomes cosine square x plus sine square x over cosine x. And remember that this one, the cosine square plus sine square from the Pythagorean identity is equivalent to what? 1. So therefore, we have 1 over cosine square of the value of the angle x. But the 1 over cosine, the reciprocal of sine, cosine is secant. And this is cosine square. So therefore, this must be what? Secant square. So the derivative of the tangent is the square of secant. Okay? So we have this proof of the derivative of the tangent. So again, the derivative of sine is cosine. The derivative of cosine is negative sine. And the derivative of the tangent is square of secant. Secant. Okay? So these are the derivative of the primary trigonometric functions of the 6 trigonometric functions. So the secondary are the reciprocal. So what will be the derivative and the graph of the cotangent? What will be the, and also with the secant and the cosecant. So let's have the cotangent function. So what will be the graph? Okay, now similarly, the cotangent of x in a fundamental identity, this is equal to cosine of x over sine of x, which means again that the cotangent don't have a real number. It don't have the domain is not a all real number. It is a real number, but take note that the sign should not be 0 here. So we can find the cotangent if the sign function is not 0. So the question is, where will be the sign function becomes 0? And what angle? The answer is at the origin, or when the angle is 0, the sign is 0. So therefore, the cotangent does not exist on this boundary. It doesn't have function when x is equal to 0. Also with the pi, 180 degrees, and the 2 pi. In the negative, we have the negative pi, and we have negative 3 pi, and so on and so forth. Okay, so therefore, if we analyze between 0 and pi, take note that it does not exist at this boundary. So the only way is to have this curve between and asymptotically towards y. So this is the result of the graph. If you evaluate the tangent of an angle very close to 0, it approaches asymptotically and reaches to negative infinite, positive infinite for y. Now, if we substitute the value of x very close to the angle pi, angle pi, it asymptotically arrive at the negative y-axis in the x, which is equal to pi. So this will be the behavior between this boundary. So similarly, we have the symmetric curve on the other boundaries. So we have that one, and also this one, and the negative angles. So this is the graph of the cotangent function. So if this is the graph of the cotangent function, what will be that derivative of the tangent of the cotangent function, or the slope of the tangent line is called? So the answer is, the derivative of the cotangent is negative secant squared. So take note, the tangent is positive secant squared, but the derivative of cotangent is a negative cosecant squared. Okay, so what will be the proof? So similarly, take note that if the tangent is sine over cosine, And therefore, the cotangent, which is the reciprocal of tangent, is also what? Cosine, the reciprocal of that, the cosine over sine. So we can replace any of this. So the question of what is the derivative of cotangent of x, it's just the same as finding the derivative of sine of x over, cosine of x over sine of x. Now with this, we can apply the quotient theorem. So the quotient theorem, the derivative of u dv, uv is v du minus u dv all over v squared. So this is it. This is now the result. And again, remember that the derivative of cosine is negative sine, while the derivative of sine is cosine. So substituting the values here, we have here negative sine for this cosine, and we have the cosine for this derivative of sine. Now this is sine x, so this is sine x squared, and it's negative. While this one, cosine times cosine, this is cosine squared, negative also. So this is the result. Okay, so if we take the common factor of negative 1, because it has a common factor of negative 1, this will become what? Sine squared x plus cosine squared x, all over group with a negative. Okay, so but what is sine squared x plus cosine squared x? Remember, this is from Pythagorean theorem, Pythagorean identity. This will become, this is equivalent to 1. So from the Pythagorean identity. So which means that we have only, this can be reduced into negative 1 over sine squared 1. But remember, the reciprocal of sine is secant. So therefore, this will be reduced to, cosecant. So this will be negative cosecant. The reciprocal of sine is cosecant. So this is the derivative of cotangent. It is a negative cosecant squared of the angle x. Okay, so we have completed the 4, so we still have 2, no? Because there are 6 trigonometric functions. Now this time, what is the derivative and the graph of the secant function? So from the Cartesian again, take note that secant of an angle x is equivalent to the reciprocal of cosine of x, which means that the secant does not exist when the cosine is 0. So what will be the angle that produces 0 value? So the answer is, it's found in the y-axis of the angle. So it's 90 degrees. It's also from 270. Okay, then we have the negative pi over 2, a negative 3 pi over 2, negative 270 degrees, and so on. Okay, so we have this. Then, so what will be the curve between the negative 2, negative pi over 2, and pi over 2? So if you substitute this, if the angle, take note, if the angle is very close to negative pi over 2, it will what? It will positive asymptotic to the y-axis at negative pi over 2. And asymptotically also to the y-axis at x is equal to very close to pi over 2. But when the angle is 0, this will becomes 1. The cosine of 0 is 1. So 1 over 1 is 1. So therefore, this one is exactly 1. And this will be the curve of the secant function. Now, in the next boundary between pi over 2 and 3 pi over 2, take note that if it is approaches to pi over 2 from in the left side becomes asymptotically towards a negative y at a distance closer to pi over 2. Similarly, in 3 pi over 2 also, the function of secant is asymptotic to the negative y. But for the angle of pi, the cosine of pi is 1, negative 1. So therefore, this is the value. Symmetrically, if you do it in the next boundary, it is on the upper part. Now, in the negative angle, it found between negative 3 pi over 2 and pi over 2, it is open downward. So, symmetric. For the next, it should be open upward. That's it. So, and so on and so forth. This is the graph of the secant function. And this graph, again, this curve are symmetric to each other. Symmetric. So, the question is, what is the derivative of this curve? Or this curve? Or any of this curve? Because they are symmetric, so therefore, the derivative must be the same also. So, what is the derivative of secant function? So, the answer is, the derivative of secant is secant x times the tangent x. Why? What's the proof of that? Okay? So, all you need to do, again, do it the same. The secant function is equivalent to what? 1 over cosine. So, the question of what is the derivative of secant, it is just the same as evaluating the derivative of 1 over cosine. The reciprocal of cosine, remember, is secant, vice versa. So, apply the what? Apply the quotient rule. The derivative ub is b du minus u dv over b squared. So, do it. So, copy the cosine, take derivative of 1 as numerator, then this time 1 will be copied, then take derivative the denominator, then square the denominator. Then we have this one. Now, remember that the derivative of 1 is 0. This is 0. While the derivative of cosine is negative sine x. So, substituting these values, this is 0, okay, and this is negative sine. This term becomes 0. And this is negative, and this is negative. So, therefore, it is a positive sine x over, take note that the cosine squared x is the same as cosine times cosine of x. But the sine over cosine, if we split this one and forming two fractions, the sine over cosine is tangent, while the 1 over cosine, the reciprocal of cosine, is secant. So, in other words, the derivative of secant, again, is secant x times tangent x. So, therefore, this verifies the derivative of the secant x. That's it. Now, lastly, we have the function, cosecant function. Now, what is the graph and what is the derivative of the function? Secant. Sorry, this is cosecant function. This should be cosecant. Then, okay, the cosecant is the reciprocal of what? The reciprocal of sine. So, therefore, the cosecant does not exist when sine is equal to 0. And the angle that provides sine value of 0 found in the x-axis of the angle. So, it's 0 angle. It can be pi of pi, 2 pi, negative pi, then negative 2 pi. These are the restricted lines, which means that with this line, the cosecant does not exist in that. It should be restricted line. These are the restricted lines. So, what will be the curve between 0 and pi? 0 and pi. This will be the result. Asymptotically positive to y, closer to 0 and closer to pi, but in pi over 2, the cosecant is 1. The cosecant is 1. So, therefore, okay, it's the result. Now, in the next boundary between pi and 2 pi, it is symmetrically downward. Okay? And at exactly 3 pi over 2, it will provide negative 1. And this is the curve. So, this is the... Now, again, we can predict the next boundary here. Then, in the negative angle, and we have this one, and so on and so forth. So, this, if you continue, then you can find this one. So, this is the graph of the cosecant function. Now, what is the slope of the tangent line to this curve? Or what is the derivative of the cosecant function x. Then the answer is the cosecant x. The derivative of cosecant x is negative cosecant times cotangent. Now, if you, in our previous slide, the derivative of secant is secant x times tangent, while the cosecant, the derivative is negative cosecant x times the cotangent x. That's the proof of this. So, similar to the previous. So, but take note that again, the cosecant is just same as the reciprocal of secant, sine. So the derivative of secant is just finding the derivative of 1 over sine. So apply again the quotient rule of differentiation. Copy, then derivative, then copy, then derivative, then square. So this is the result. The derivative of 1 is 0, so this is 0, while this one is cosine. So substitute the values, then this term becomes 0. Multiplied 0 in the number becomes 0, and this is cosine, so this negative sine, negative cosine. So we have this value, negative cosine over the sine squared is the same as sine times sine angle x, but we can combine, can provide two fractions. So the cosine x over sine x cotangent, while this one reciprocal of sine is cosecant, and it is a negative. So therefore, it provides the proof of the derivative that the derivative of cosecant x is negative cosecant times the cotangent of x. That's it. Very clear. So we understand what's the graph of the Fourier function and what is the derivative of that function. So this is the answer. Now let us summarize the six. What are the six basic derivatives of trinity functions? The six circular trinity functions. We have the sine derivative is cosine. The derivative of cosine is negative sine. Okay. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. While the secondary cotangent secant, the secant is derivative secant x times tangent x, and for the cosecant is negative cosecant x times the cotangent x. These are the six trigonometric functions. Okay, so you need to memorize on, you need to have the derivation of this. That's it. Okay, now let's apply the derivative of the trigonometric function. Suppose you're given the problem, find the derivative of the function. The function is 5 cosecant x plus tangent x. Then after that, evaluate the derivative when x is pi over 2. So our solution starts from what? From finding the derivative of this function. So all you need to do is to take derivative, the 5 cosecant of x plus the cotangent of x. Then okay, so we can apply the sum rule. So we can apply the sum rule, and take note 5 can be placed outside the derivative operator because it doesn't affect the operation. So then this will be the result. It is 5 the derivative of cosecant x plus the derivative of cotangent x. Then recall our theorem. Our basic theorem can be applied because this is cosecant and this is cotangent. So what's the derivative of cosecant? It is a negative cosecant times cotangent, while the cotangent is a negative cosecant squared. So substitute the values. These are the derivative, and after that simplify, or you can leave this as your answer. Anyway, you're asked what is the derivative when x is equal to pi over 3. And take note, pi over 3 is 60 degrees. So to do it, replace all angle x's here with pi over 3. So therefore, we are now to evaluate what is the cosecant of pi over 3, cotangent of pi over 3, and what is the cosecant squared of pi over 3. So you have to provide the exact value. So I have to recall the previous video, no? So that's why in our previous videos are the basic requirements in order to answer the problems in derivative of the function. So we need to recall the special angles, the 30 by 60, because take note that pi over 3 is 60 degrees, while the pi over 6 is 30 degrees. So according to the 30 by 60, the side opposite to the 30 degrees must be 1 unit. Then the hypotenuse is twice as much as that. So therefore, this side is 3 pi square root of pi, square root of 3. So with this, we can apply the trigonometric sukatua in order to evaluate this one. Now remember that the cosecant is the reciprocal of what? Sine. So the sine of 60 degrees is, take note, opposite of hypotenuse, which means that the cosecant is hypotenuse over cosecant. So for the 60 degrees, pi over 3, and the 30 degrees pi over 6. So the cosecant of pi over 3 or 60 is 2 square root of 3. Opposite, hypotenuse over opposite. Now for the cotangent is the reciprocal of tangent. The tangent is opposite over adjacent, so square root of 3 over 1. So therefore, the cotangent must be reciprocal. It should be 1 over square root of 3. Adjacent over opposite. So this is the cotangent. And again, the cosecant squared. So the cosecant squared becomes what? It is pi over 3 square root of 3 squared. So substitute the values for the cosecant of pi over 3. This is 2 over square root of 3. Set. For the cotangent of pi over 3, it's 1 over square root of 3. While the cosecant again is 2 over square root of 3. But this is raised to 2 because this is squared. So evaluate, use algebra. If you multiply the square root of 3 times square root of 3, the answer is 3. So therefore, and negative 5 times 2 times 1 is negative 10. So this should be negative 10 over 3. While this is 4 over 3 because squaring this is square, 2 is square root of 3. So the answer is negative 10 over 3 plus negative or minus 4 over 3. So combined, we have 14 over 3. This is the answer. This is the derivative of this function at x is pi over 3. That's it. So this is the answer. So you cannot arrive this answer without the knowledge in what? In the basic trigonometric function of the derivative. And also, you cannot run the solution without the knowledge of the exact value. And also, you cannot provide the theorem without the identities. So that's it. Very clear. We need the requirements. The requirements are exact values using the special angles, circular unit circles, and the identities of trigonometric function. Okay, now next. Suppose this is the problem. So what makes difference to this problem? Evaluate the derivative. Okay, but evaluate this the derivative of sine of 5x. So what the difficulty of course on this? Why? Because the angle is not x, it's 5x. It is different, no? We cannot say that the derivative of sine of 5x is cosine of 5x. No, it is not. Okay, so what will be if you are given it? So meaning you cannot apply the basic, no? You cannot apply the fundamentals of or the basic theorem of trigonometric function. Why? Because the angle is not the domain. So it is a combination of domain and other coefficient. Then the question is, find the second order derivative, not just by the first, continue to the second order derivative. So to answer this one is find first the first ordinary derivative, first order derivative, then derivative, differentiate again to obtain the second order derivative. So how will you do it? So for your solution, so since we cannot apply the theorem, the basic theorem of differentiation, then we can use the technique, which is the composite. So the ultimate, or the basic approach is to use the composite or the chain rule technique, because we cannot consider this function as a composite. So you have to start with letting u be equal to 5x, because the 5x makes this function composite. So make it simple, make it as one part, and let use a dummy variable u. So let u be equal to 5x. So therefore, your y now, or your function, your y becomes sine of u. So it's simplified with this one. So you can notice that we have only one variable here, and that is u. But take note, u is a function of x. It is not x. U is a function of x. So chain rule says that you have to differentiate du with respect to x. So find the du over dx, and the answer is 5. Du dx, the derivative of u with respect to is 5, using the theorem. While the derivative of sine of u with respect, derivative of y with respect to u is cosine of u. Okay? So we have these two values, the du, and we have the du dx, and we have the du dy. These are the important components for the chain rule, because the chain rule says in order to obtain the derivative of y with respect to x, this is the requirement, is to multiply these two factors, the dy du and the du dx. Why we multiply these two? Because this forming a chain. Actually, if you do it mathematically, this will be cancelled out. This will be cancelled out. And we have this as dy dx, which means that the dy dx can be expanded into a form of dy du, du dx. That's the meaning of chain rule. So therefore, since we have this one, so substitute it here. This is cosine of u, while du dx is 5. So that's it. So it should be cosine of u times 5, where cosine of u is du dy du, and 5 is the du dx. So this is now dy dx, or the derivative of y with respect to x. But what is u? U, remember, is 5x. So you have to replace u with 5x. So therefore, look at this one. The problem is, what is the derivative of the sine of 5x? And this is not composite, treated to be composite because this is not 5. Which means that you cannot apply the basic. But when you look at the result, when you observe this result, there are two answers, two factors of the answer. First is, we have the cosine of 5x, which means that derivative of the sine of 5x is cosine. So following the theorem, 5. You have to copy the angle 5x, but you need to multiply it by 5. Now, what is this 5? This 5, remember, is what? The derivative of u with respect to x. So meaning, this is the derivative of 5x. This is the derivative of 5x. Okay? So, therefore, without using the chain rule, you can still do it. Without using the chain rule, evaluating the sine of the 5x is just use the theorem as it applied, cosine 5x, but you need to multiply it by what? The derivative of that function that makes composite. And this case becomes what? 5. Okay? So then, you can rearrange this one, and you can leave this as your answer. 5 cosine 5x. So the only difference is we have this factor 5. So if you do it in the second order, because this is the first order derivative, if you do it in the second order derivative to answer this question, then we need to differentiate it again. We need to differentiate the first order derivative, which is dy dx, and this is 5 cosine of x. So if we take note that 5 is what? 5 is constant, so you can place it outside, okay? And what is the derivative of cosine of 5x? So you have to do not use the chain rule anymore. So use this pattern, okay? This one. Okay. So what is this result? Okay. What is the derivative of cosine of 5x? The answer is, it should be what? Negative sign, because cosine is negative sign. And copy this 5x. But you need to multiply it with what? Derivative of this function, which happens to be 5. So meaning, this one is negative sign 5x multiplied by 5. But 5 times 5 is 25. So therefore, this will be the answer. The negative is coming from the cosine. Derivative of cosine is sine. And this 5 again is 5 times 5. So if you differentiate again, then this will become cosine 5x times 5 again. So 25 times 5. That's it. That's the second order derivative. So meaning no need to use the chain rule. The chain rule, the chain rule solutions will explain to us on how it was obtained. But because of the result pattern, then no need to use the chain rule. So if we analyze this one to general, meaning if we have this sine kx where k is a constant, a coefficient, then the answer is cosine of kx times the derivative of this, which is k. So k cosine x. So for the cosine, it should be negative k sine x. Now this is only true for what? For a number, let us say 5x. But we can expand this if this is what? A function. Meaning, suppose this is x squared plus 3x plus 1 is the angle. So what will be the sign? So then, the answer is u, okay? Leave it as, what is the derivative of sine u, where u is a function of x? Then, the answer is, derivative of sine is cosine, so cosine u, but you need to differentiate it to u. So take the du with respect to x. That's it, and that's the answer. Similarly, for the cosine, it should be negative sine u times du. That's it. Okay? So this is more general than the kx. So remember nga, I presented only two, the sine and cosine. Why? Because remember that if we have the sine function and cosine, we can obtain tangent, we can obtain the reciprocals, and the 6 trigonometric functions can be provided. So we using this two only, then the 6 trigonometric functions can be obtained. Okay, so then that's it. So let's solve again the problem. So for this problem, you are asked to find the x sine x plus cosine. So what makes difficult to this problem? Not so difficult. Observe that this x cannot be removed. No, you cannot remove this or transfer this. Why? Because this is a domain. So it forms product, which means that the solution to this problem is to apply first the sum rule, then after that apply the product rule. Okay, so this is now the sum rule representing to this problem. Sum rule, okay, this is the first, but this is the derivative using the product rule. So this is product rule, using product rule. So copy, then take the derivative of sine one at a time, sine times derivative of x. So this product rule, and this one is the cosine. Leave it as a cosine. Okay, so therefore we are now ready to evaluate that the derivative of sine is cosine, the derivative of x is 1. So therefore this will be the result. This will be what? X cosine plus sine x, because this is 1, and the derivative of cosine is negative x. Then simplify. Okay, so if you remove the grouping symbol, again this will be cancelled out. So therefore the answer is just what? X cosine of x. But this is not the answer. Why? Because you are asked what will the derivative of this function when x is pi. So all you need to do is to replace all x's with pi to evaluate the derivative at x is equal to pi. So therefore, this will be pi cosine pi, but the cosine pi is -1. So therefore, the answer is a negative pi. This is the simplest way to present your answer. That's it. Okay. Next, last problem. Okay, now what will happen if you are given this kind of problem? It's quite complicated. Why? Because it has a numerator and contains two terms, and it has a denominator of two terms. So what will you do? So don't panic. No, all you need to do is to analyze what will be the first theorem to be applied. So your solution starts with what? Using the theorem of quotient rule. So apply the quotient rule. And after that, simplify, then simplify. Then after that, differentiate. Okay. So then, quotient rule, u over b is v du minus u dv. So then square the v. So we have this one. Copy the denominator, then differentiate the numerator, then minus this time. Copy the numerator, then differentiate the denominator one at a time. Then square the denominator. And after that, you can, for this is, remember, this is part of the answer. And also this one is part of the answer. All you need to do is to evaluate this integral. So to evaluate the integral is to apply the sum rule. So derivative of 1 is 0. Derivative of sine is cosine. Derivative of 1 is 0 again. The derivative of cosine is negative sine. So negative becomes plus. Substitute the values. The denominator of this is also part of the answer. So again, this is okay. This is copy, and this is only cosine. This is the derivative of this 1 plus sine because it's 0, and this is copied minus derivative of 1 is 0, and this is negative sine times negative becomes positive sine. This is it. Okay. You can remove the grouping symbol. No, distribute. Then is the result. Becomes cosine x minus cosine squared x, and remove the grouping symbol. Be careful, your algebra. This one remove, becomes negative sine x minus sine squared x. That's it. Okay. Take note that this one have the same sign negative, and this is cosine square, sine square, the same angle. No, if they have the same angle in the square, then Pythagorean identity is now will comes in. It is equivalent to -1. If this is positive, this is equivalent to +1. But because negative, this is equivalent to a -1. So this is the value for the cosine and sine squared. So therefore, that's it. So what next? Is this the final answer? Yes. This is already the final answer. This is a simplified form. So with that, you answered the problem. Okay. Now there are many problems that you can apply. You can solve. No? So just practice. No? Keep on solving, because the moment you solve, more problems you solve, more knowledge na imo mo pick up. So it remains to your mind if you have a lot of problems nga imo na solve. So therefore, for your practice, kindly solve this one. All of this, try yourself to. By the way, this problem was already solved. This one, so solve again, but in your own idea, in your own solution. Okay, we have also this one. So try to solve this problem. I give this problem, this one. So actually, this is a problem that cannot be solved using this. It needs another. So this leads us to study the exponential, the derivative of exponential function, the logarithmic and exponential derivative. So that will be our next topic. Okay, so that's all. Thank you for listening.